Let us learn about find S algorithm. Before that, we will see what type of values are taken over by the attributes in the hypothesis. Hypotheses are kind of rules which we will be following or the machine will be following in order to make decisions. The attribute values start with the null value, which means there is no value initially, and depending upon the problem, the value of the attribute is going to change to a specific value. Specific value means in case we have the attribute sky, in finders algorithm, it requires only positive samples. For the instance where sky is equal to sunny, output is yes. So this sunny will be taken as a specific value for an attribute. So here instance will be having multiple attribute values. One of that will be sky and that sunny was selected in the first go and that is going to be allowed to the attribute value. The next type is question mark, where if we have multiple values for the same attribute for this with the same outcome, then we can make use of question mark. For example, in case we have another sample where sky is equal to sunny and outcome is also yes. So for both the values of sunny and rainy, for both these values, output is yes, that is same. Multiple values are allowed. So in this case, such attribute value will be set to question mark. So in this case, null is said to be most specific value. It means that there is no value, and question mark represents a general value, which means that any value is allowed. So if we have question mark in the hypothesis, any value is allowed for that particular attribute. So we don't have to check there. Only specific values will be considered for checking. So example is number of attributes to be equal to 3, and if you are representing most specific hypothesis, it is going to be allotted with 3 null symbols, and if you want most general hypothesis, it is allotted with 3 question marks for 3 attributes. So coming to this specific and general, see all the hypotheses that are consistent with the dataset come under a hypothesis space capital H. We have so many hypotheses in this. So H0, H1, H2, H3 and so on till Hn. These are divided into specific boundary and general boundary like equal division. So the general boundary starts with allowing any value to the hypothesis attributes, whereas specific boundary starts with allowing no value to the attributes, and they both approach each other while they are getting processed. This is a common point for both the boundaries. So all the hypotheses on the specific side are represented by capital S, like you can tell S naught, S1, S2, and all the hypotheses on the general side are represented by capital G, like G naught, G1, G2 and so on till they reach this point. So in case any processing does not reach this point, if they are different, we are going to converge them together, forming a new rule to club the entire hypothesis space. So here hypothesis is represented by small h's, that is individual hypothesis represented by small h. Set of hypothesis is represented by capital H, that's nothing but your hypothesis space. An instance is represented by small x and set of instances is represented by capital X, which I'll show you now. The outcomes are categorized into 0 and 1, or we can have yes or no values or true or false value. Any boolean type of a value can be added. So in case the given test instance is consistent with the hypothesis function returns 1 as the value, which means that classification is positive. So if we have a positive classification, it means that h of x got equal to 1. So if we have classification as negative, that means h of x was obtained or was assigned with 0 value after processing or comparisons. This is the algorithm for finders. As the name indicates, finders means it is going to find the specific hypothesis. So we are going to operate on the specific side. Just now we have seen specific side initializes the hypothesis with the most specific, that is null value. So that is the thing happening here. We are going to assign with the null value for the number of attributes we may be having in the problem. Then finders algorithm considers only the positive training instances. So it's going to check what is the output, that is if it is a last column, output will be checked, yes, no, yes. Only these type of samples will be considered to affect the hypothesis. So how will it affect? It is going to check every attribute and follow the rules that I have given for the attribute values. Once the specific value is found, that specific value will be allocated at that particular place. And in case there is another attribute with the different value, like if it is x here and if it is y here, same value but outcome is yes, means that converts to question mark. Same rule will be followed in the specific side. And at the end, all the samples will be referred to, and then again we are going to get the final hypothesis. For example, they have taken the enjoy sport example. So here we have six attributes: sky, air, temp, humidity, wind, water, and forecast. Each have their own domain. Sky has the sunny, cloudy, and rainy possible values. Then air temp has warm and cold. Humidity has normal and high. Wind has strong and weak. Water has warm and cool. Forest has same and change. And this is the data sample. So in this data sample, this column is called as the target concept. That is for enjoy sport, we are going to calculate the value, classify. So whether it is yes, S or no S or whatever it may be, depending upon the test. So this sample is used for testing purpose. This entire sample is termed as capital D, in which we have again the left part of it, that is only the value side is capital X, that is set of instances, and this is called as target concept, right? Concept represented by C of X means we have concept for a given X, wherein here each row is represented by small x, x1, x2, x3, x4. So C of X is yes, that is outcome of X is yes, and in this case it is no. So these are the representation for the parts of the data set. Now we will see how the problem is solved. Pardon me. So according to the rule, we are supposed to start with the most specific hypothesis. So our H naught will be equal to, since we have six attributes, six null values. I said no need to use comma. You can use the comma. Whether you use or not, both are good. No problem whether you use or not. So H naught is assigned with six null values. So we are going to go for the first instance in the table, that is x1. X1 will be, if you see in the table, sunny, warm, normal. Then we have strong, warm, same, and their outcome, its outcome is yes. So it is a positive sample, hence finders algorithm is going to make use of this. Since it is the first iteration, whatever value is there in the first positive instance, same thing will be assigned, that is a specific value allocation. So sunny, warm, normal, strong, warm, and same. This is what we have in our hypothesis now. Going to the second iteration, that is second sample. Second sample has these values: sunny, warm, high, strong, warm, and same. The outcome is yes. So here we need to check each attributes. Since it is yes, it is accepted for processing. First attribute is similar. So H2 first attribute is remaining as it is, sunny. Next, second attribute is similar again. We will make it as warm. Going to the third attribute, we have normal here, high here. This is taken from the positive sample, and this is also a positive sample, which means both normal and high are allowed. So this third attribute will be converted to question mark. Next we have strong, strong, warm, warm, and same, same. So they remain as it is. So strong, warm, same. This is the hypothesis at the end of the second iteration. Going to the third one. Actually, it is supposed to check for outcome. So I'll just write down what is there in the third one. So rainy, cold, high, strong, warm, change. Outcome is no. The algorithm checks the last column first. Since it is not yes, since it is no, this sample will be discarded. So X3 is discarded. Why? Since it is negative sample. So at the end of the third iteration, H3 remains same as H2. So sunny, warm, question mark, strong, warm, and same. Let us go to the fourth sample now. X4. X4 has sunny, warm, high, strong, cool, and change. These are the values and outcome is yes. So it is going to be allowed for hypothesis updation. So H4. Sunny and sunny are same. It remains as it is in the hypothesis. Warm and warm are same. It will be as it is. Next, strong, the third one is question mark. Since it is allowing for question mark already, no need to go with the updation. So question mark. Here strong are same. So fourth parameter remains as it is. Coming to the fifth attribute, we have warm and cool. That is, multiple values are allowed for fifth attribute. We convert it into question mark. And last one also, same and change, we have multiple values allowed. We convert it into question mark. So this will be the resulting hypothesis for find S algorithm.